Hello and welcome to Earthquake Tip number 12. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. Before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 12 will explain you how the most prevalent construction practice across India, that is brick masonry construction, behaves during earthquakes. As explained to you in the earlier tip, masonry is brittle and so are masonry buildings. The structures built with masonry are most vulnerable of the entire building stock during strong earthquake shaking. The large number of human fatalities occur due to failure of such buildings, and it has been seen during most of the earthquakes that took place in the country. Therefore, it is of paramount importance that to improve seismic behavior of masonry buildings, which can be done by introducing number of earthquake resisting features. Now let's understand the behavior of masonry buildings. The masonry buildings comprise of three components, namely roof, walls, and foundation, as shown in this figure 1A. Ground vibrations during shaking cause inertia forces at location of mass in a building. These inertia forces travel through the roof and walls to the foundation. The main objective is on ensuring that these forces reach the ground through these components without causing major damage or collapse. Of masonry buildings, the walls are most vulnerable to damage caused by horizontal forces due to earthquakes. As you can see in this figure 1B, the wall topples easily if pushed horizontally at the top in the direction perpendicular to the plane of wall, which is called weak direction. However, the wall offers much greater resistance if pushed along its length, that is, in its own plane, also known as strong direction. As explained you earlier, ground motion due to earthquake is divided into two horizontal direction and one vertical direction. However, the horizontal vibrations are most damaging as horizontal inertia force developed at roof transfers to the wall, acting either in weak or strong direction. If the walls are not tied together like a box, the walls loaded in the weak direction tend to topple, as shown in this figure 2A. Therefore, to ensure good seismic performance, all the walls must be joined properly to the adjacent walls. This will ensure box-like integral action, as walls loaded in their weak direction can take advantage of good lateral resistance offered by the walls loaded in their strong direction, and same is shown in this figure 2B. Also remember, walls need to be tied to the roof and foundation to preserve their overall integrity. Having understood the behavior of masonry buildings, now let's move to understand how to improve behavior of masonry walls. As you can see in this figure, the masonry walls are slender because of their small thickness compared to their height and length. A most simple way of making these walls behave well during earthquake shaking is to ensure box-like integral action of entire building. That is, walls act together as a box along with the roof at the top and with the foundation at the bottom. The natural question comes to mind how to ensure this box action. First, connection between walls should be good, means ensuring good interlocking of masonry courses at junctions. Secondly, introducing horizontal bands at various levels. The most important one is lintel level. Also, the openings in the masonry buildings make masonry construction weak. The smaller the openings, larger is the resistance, and therefore the sizes of doors and windows need to be kept small. Further, the tendency of wall to topple when pushed in the weak direction can be reduced by limiting its length to thickness and height to thickness ratio, normally known as L by T and H by T ratios. Most of the design codes in the world specify limits of these ratios. So remember, a wall that is too tall or too long in comparison to its thickness is vulnerable to shaking in its weak direction as shown in this figure. At last, once again, let me brief you on choice and quality of building materials to improve seismic behavior of buildings. Masonry walls being brittle in nature, its earthquake performance is very sensitive to the properties of its constituents, namely masonry unit and mortar. The properties of these materials vary across country due to variation in raw material and construction methods being adopted. Also, a variety of masonry units are used in the country, such that burnt and unburned clay bricks, solid and hollow concrete blocks, stone blocks. Burnt clay bricks are the most commonly used masonry units in our country. The bricks are inherently porous and so they absorb water. Excessive porosity is detrimental to good seismic behavior because the bricks suck away water from adjoining mortar, which results in poor bond between brick and mortar. Therefore, always remember, brick with low porosity need to be used, and also soak the bricks in water before using them to lay walls, as it will minimize the amount of water drawn away from the mortar. Let us also understand various mortars being used in the country: mud mortar, cement sand mortar, and cement sand lime mortar. Of these, mud mortar is the weakest as it crushes easily when dry and has low earthquake resistance. Cement sand mortar with lime is most suitable. Also, mortar mix provides excellent workability for laying bricks, and it stretches without crumbling at low earthquake shaking and bonds well with bricks. The earthquake response of masonry walls also depends on the relative strength of brick and mortar. Bricks must be stronger than mortar. Excessive thickness of mortar is not desirable. Normally, a 10 mm thick mortar is generally satisfactory from practical and aesthetic considerations. Indian standards prescribe preferred types and grades of bricks and mortar to be used in building in each seismic zone. This is all about earthquake tip number 12. You can download this tip from www.bmtpc.org. The next earthquake tip number 13 will be on why should masonry houses have simple structural configuration. Thank you very much.